Good morning to all of you. Especially, I would like to convey my thanks to Teaching Learning Center and Department of Economics, Ramanujam College, who has given me this opportunity to deliver the lecture under the aegis of Pandit Madan Mohan Malviya National Mission on Teachers and Teaching, which is a 2-week refresher course in economics. Focusing on sustainability strategies perspective from India. So I would be discussing on the domain renewable energy and targets, focusing more towards charting uncharted renewable energy sources of geothermal energy. So let me just give you a small introduction of myself. I'm Professor Shibani, Associate Professor in the Department of Civil Engineering, Birla Institute of Technology and Science currently. Now, let me proceed with the today's talk. As we understand, energy is one of the major component of achieving the sustainability targets. So I will be focusing on this content of the lecture, which is energy classification and renewable energy in itself. Then index study for prioritizing renewable energy alternatives and source locations, and geothermal energy status and potential assessment. So this will be the major content of this particular lecture, which we'll be covering in 3 parts. Expected learning outcome from this lecture would be to classify energy and relate with the history of renewable energy, and at the same time, to develop renewable energy alternatives and source location priority index. And third outcome is to develop models to assess geothermal energy resource potential. So I will be introducing different feasible renewable alternatives in current scenario. At the same time, I will see how geothermal energy can be one of the viable and strong element in the renewable energy basket itself. First, let's look at the first part of the lecture, which will be energy classification and renewable energy history. So in a general notion, we classify energy based on primary and secondary energy uses. So which again depends on several layers of classification based on the source, based on the extraction, based on processing, and then we define primary and secondary energy. So based on source, it's a very conventional form of sources are coal, hydro, nuclear, natural gas, petroleum. And again, all these sources have a different mode of extraction. Like for example, as you can see here, let me just show you laser point. So open and deep mines, then again hydro, which is mostly in a power station, it generates the electricity. And whereas nuclear, like extraction methodology of mining is used, natural gas, gas well, petroleum, oil well. And then it goes to the further processing unit, and we have different forms of processing output like enrichment, treatment, cracking, refining for petroleum, for example, and which lead us to primary energy sources like in form of coal and coke from the coal. So after preparation, coal is obtained, and then purification, it gives rise to coke, and so on. So then finally, yes. So for, as you can observe, for all these sources are finally used at power station to generate electricity. Apart from that, we have thermal and steam energy as well as the secondary form of energy. Now, coming to another way of classifying energy, which is based on the commercialization. So we call commercial energy, where electricity, lignite, coal, oil, natural gases are different forms of commercial energy, whereas a non-commercial, where it is just used locally, like firewood, agro-waste in rural areas, solar energy, animal power for transporting, threshing, wind energy for local lifting of water, and so on. Further classification is based on non-renewable energy, where you have already seen some of this form like coal, natural gases, oil, nuclear. Non-renewable energy is the form of energy where it cannot be replenished. The sources cannot be replenished, whereas another form classification which falls in renewable energy, where the sources gets replenished by its own, like for example solar energy, water, where we call hydrokinetics, wind, geothermal, and biomasses. So in course of time, we will see like these 5 forms of renewable energy, which is mostly taken into consideration, whereas geothermal is, in case of India, this is what we will target today as a lecture, which is not taken into consideration as electricity generation source. However, other four renewable sources has been already explored, and it's also contribute to our renewable energy basket. So before moving into discussing about this geothermal energy scope, let us have a small glimpse of a history of renewable energy. As we understand, this biomass is one of the form of renewable energy. It is credited to, since the civilization, we have the civilization on this earth, like it has been identified 400,000 BCE again. So we understand what is biomass. It is the form of energy which is obtained from the material from living or recently living organism, unlikely fossil fuels, which are materials from long dead life forms. So coal is one example of fossil fuel. Now, the discovery of fire, the process of converting this chemical energy in biomass to heat and light, it's one of the mankind's first and perhaps most important discovery as we know. Looking at the another form of energy, which is wind energy, this is also a quite old form of renewable energy, credited to 1700 BCE. It is well known. There is a well-known story that Babylonian emperor Hammurabi, who was known for his code, he had planned to use wind power to irrigate farmland almost 4,000 years ago. However, as far as the earliest known instance of using the wind energy, it is credited to Greek engineer Heron of Alexandria's wind wheel in 1st century. So now looking at the current status, today wind farms generate billions of watts of clean power, and costs have fallen such that wind energy is approaching that of the coal itself. So this another form which again contributes to renewable energy is hydrokinetics, which goes back to 200 BC. So where over 2,000 years ago, the ancient people of India, China, and Imperial Rome built water wheels and water mills to grind grains into flour and saw timber and stone. So this is actually another form of old renewable energy which was already in practice. However, in today's form, if we just look into, the challenges are even more advanced, where the extracting the energy from rivers and ocean currents without damaging the delicate environment, because environmental concern is one of the major issue in current days, in which aquatic life makes its home. So here, as you can see, one of the example of this renewable energy of hydrokinetics, which is the dam known as Haditha Dam, which is one of the largest hydro contributor to the power in Iraq, which has a capacity of 660 megawatts. So in India also has many such big dams. We are not indulging ourselves in this lecture to discuss about those. We will focus more on a particular form of renewable energy, which is not discussed mostly in Indian context. So let's come to another form of renewable energy, which is solar photovoltaics, which is relatively new in 19th century, which has been actually observed by Heinrich Hertz, where he has observed that photoelectric effects where light hitting certain substances causes electrons to flow and creating electricity. And that was further strengthened by Einstein's detailed explanation, for which he has also won the Nobel Prize. And as we understand, current status is like recently researchers are trying to even bring down the cost and raise efficiency of this photovoltaics using the principle of quantum physics at nanoscale. So finally, coming to the 5th form of renewable energy, that is geothermal energy, which is again formally, it has been understood in 20th century, 1905, where first geothermal project took place in Italy. However, there is a story behind this, is that a farmer drilled a well and hoping for some cold water, and he, instead of receiving the cold fresh water, he got hot water, which turned into steam. So with this observation, there was a very beautiful concept was born, that why not to put turbine on that steam and produce the electricity. And that is what happened finally, in form of electricity generation from the geothermal energy. Now, if we look around the worldwide status of geothermal plants, we can find here that baseload power, this geothermal energy is responsible for contributing as baseload power, clean energy, which is available for 24 hours a day. So the important aspect of this growth of renewable energy, which represents a fact which can be found here in terms of currently creating 5 times more job, job than the fossil fuel domain. Renewable energy jobs, which has grew from 1.7 million jobs in 2004 to 10.3 million in 2017, and now further 11.5 million in 2019. It was reported by International Renewable Energy Agency. So we understand that as renewable energy grows, so do the jobs itself. Now let's focus on the electricity by energy sources in India. So as you can see here, this has been, it's a very common result, which is known to all of us. So here, different form of energy, you can mostly focus on the fossil fuel electricity dependent on fossil fuel, which is still too large, actually quite high compared to other forms, where other renewables and hydro and nuclear, you can see. So the current renewable energy target is to reduce this fossil fuel, which you can see here. In recent, it has started showing the declining trend, however. So now let's focus on the different elements of renewable energy itself. In context of India, you can see that hydro takes a major share in the renewable energy, following the wind and then biomass and solar. So currently, it is India is considered as world's 3rd largest renewable energy producer with 38% of energy capacity. It is been found in 2020 that 136 gigawatt out of 373 gigawatt is produced from renewable sources. So also a study indicates that renewable energy country attractiveness index is actually putting India at 3rd rank behind USA and China. Now, recently in 2021, India had a renewable energy capacity of 150 gigawatt, consisting of solar 48.55 gigawatt, wind 40.03 gigawatt, and so on. You can just see the small hydropower, biopower, and large hydro and nuclear. So these are the components which has been included into the renewable energy basket. So a current commitment from India is that achieving the goal of 450 gigawatt renewable energy capacity by 2030. It's a huge, but this is what is the current target which has been put into a major goal. Now, let's look at energy consumption in India. When we look into, we can see still we are utilizing the energy from thermal energy sources, which is the highest share, as you can see in this particular pie chart. So, whereas hydro, which is shown here, which is again contributing to one of the greater percentage, that is 12.6%, whereas renewable energy sources altogether is 22.1. And in renewable energy, what are the consideration currently? These are small hydro project, biomass gas, urban and industrial waste power, solar and wind. However, nuclear actually shares a share of 1.9%. So with this scenario of and status of energy, it is important for us to, if we have to at all achieve the target of this renewable energy, which was put for as 450 gigawatt by 2030, it is important for uh, Indian system to explore all form of renewable energy, which we have discussed. So what we would like to discuss further in the next content of lecture is the index for prioritizing the renewable energy alternatives and source location. So alternatives, as we have seen, like 5 forms of alternatives, as we can see here, these are 5 forms of renewable energy alternatives, which was identified starting from wind, solar, hydro, geothermal, and biomass. However, currently, at the scale of an electricity generation, only wind, solar, hydro, and biomass are conventionally used. Geothermal is not addressed so far in the context of in Indian context. So here I'm going to discuss how that geothermal resource can also be one of the major element into that particular renewable energy domain. This renewable energy in India, which has put the target of 55% of the total installed power capacity by 2030. So Central Electricity Authority, which estimates that by 2930, the share of renewable energy generation must increase from 18 to 44%. At the same time, the thermal is expected to reduce from 78 to 50%. So here itself, it reflects that how much we need to promote the different elements of the renewable energy basket, at the same time to explore it to its maximum potential. Now, looking at that aspect, what we have understood from our study that geothermal energy, which is not a chartered domain so far in India, why not to look that particular domain into consideration? So we started looking at the geothermal prospects, and if you just look at the global status in terms of global utilization, you can see in the map itself that there is a scope certainly in context of India that geothermal energy can have one of the prospective sources. However, it is not in like any electricity capacity or generation capacity zone. It is still in the zero generation zone. So India, for the generation of electricity in an industrial scale, is not recognized from the geothermal resources. So this has driven us our study, like how to take this particular aspect into as a future prospect. And looking at that, let's try to understand why do we basically promote geothermal energy. To understand that, we should understand what is geothermal energy. So geothermal energy is nothing but it's the heat that comes from the subsurface of the earth. It is contained in the rocks and in the fluids beneath the earth crust, and which is actually known it is renewable in the sense where the crustal heat continuously replenishes the geothermal energy zone by heating that particular zone in a continuous flow. So as you can see here, this is some subsurface portion it has been shown. So you can see geothermal energy, which is lying at much deeper depth, which is getting heated from the crustal heat. Whereas also you can notice that in the shallow zone, where it has been mentioned as ground source energy, this is also a source of geothermal energy, where the heat is due to the solar energy getting absorbed, and it is flown into the by the flow of heat by conduction into the subsurface system. We call subsurface system, which is the portion beneath the ground. So understanding that, it is important to understand how the thermal gradient, which we call the temperature variation with the depth, it varies. If a map of this thermal gradient can be observed throughout the globe, which is not uniform, however, locally it needs to be mapped how that this thermal gradient varies, and based on the existence of this thermal gradient, which leads to exploit this geothermal energy. So gradient here, thermal gradient means the variation of temperature with the depth. So generally it is taken as with the depth, temperature will increase, and which is one of the promising factor for exploiting the geothermal energy. So let's look at the historical background of a geothermal resource, where you can see in this particular map where there are a lot of promising geothermal provinces has been shown by name, like I can just take some of them: Chumatang, Manikaran, Tapovan, Shohana, and so on, Puga. So this actually historical background already is established in India, where which is credited to Hot Spring Committee, which was constituted by Ministry of Power and Irrigation in 1963. So this committee mostly consists of various scientists from National Geographical Research Institute, NGRI, and Geological Survey of India, GSI. And they have identified 340 almost 340 thermal springs all over the country. At the same time, they have also identified some of the promising geothermal provinces and fields and localities. So from that, we have identified some of these promising geothermal fields, which are Puga, Chumatang, Manikaran, Tapovan, Tatapani, and Unbade Khed, which is located in different parts of country. So from some this historical study, some of the notable statistics of exploration can be identified in terms of the temperature which was obtained from these fields, that 6 fields which I have discussed. So and the temperature was quite promising, which was, in case of Puga, it has been obtained as 129 degree. That also you can notice, these were all explored in a shallow depth, like 382, 198, 670. So almost 500 to 600 meter. I'm sorry. So this temperature, which is of 129 degree, 119 degree in Tatapani, which it's a quite promising temperature, where one can look for the option for electricity generation from such geothermal output. Now, it is important to understand the scenario of Indian geothermal scope versus global. So in Indian context, you have already seen that it has already explored, but it was explored in a shallow depth. However, in a global scenario, if we just focus, we can find that some of the examples of geothermal field, it has been referred here, like Dupti geothermal field. You can see the exploration is quite high. It is 2,000, more than 2,000 meter. Then again, Nicaragua, one geothermal reservoir, which is Momotombo, this is also again greater than 2,000 meters, so 2 kilometers nearly. Some other examples are shown here in New Zealand. You can see here more than 3,000, 3,492. Like almost it is in the range of 2,000 to 3,500. So if we just compare the Indian scenario, it is in contrast with the global scenario. So issues needs to be identified why in Indian context actually geothermal has not given importance. So issues lies with this, that is geothermal energy is a reasonable source to meet the increasing demand. Second, where can it be extracted in India, and what is it the most significant, if we can explore the most significant location, then how can we extract this hidden potential, and what is the best practices to extract? Then further moving on, how much potential can we extract from that particular field or reservoir? Then the sensitivity of the operational parameter on extractable potential, and how long can we extract? These are some of the issues which lies with the geothermal energy. Then challenges here, once identifying that how best each of the renewable sources relative to other, because it is important when we, as a scientist or researcher, we explore some new domain. We also need to take into account the stakeholders. For that, it is important to establish the fact whether this particular alternative is feasible, viable, or how much strong enough to take place into the renewable energy basket. So one of the challenge was to establish that particular fact. So each renewable energy source, how best they are related to the other. Then also when it is in the exploratory or initial stage of exploration, it is also important that the scope for geothermal fields, which has been identified as some of the major provinces and field. So where to start this exploration or where to start the pilot study, it is important to establish the fact that is the relative dominance of geothermal field, where a stakeholder can take the input from this particular aspect so that they can take the pilot study into account and to establish this particular technology. Then the other challenges are for researchers and scientists, like already identified geothermal provinces, which is only studied for shallow depths. So how to take it forward for the larger depths? As you have seen, Indian scenario is in contrast with the global scenario. So larger depth studies are not existing. So geothermal fields needs to be studied for deeper zones, and it should be mapped for the higher depths, like 1 kilometer and more than 1 kilometer depths, and further establishing the conceptualization of those fields so that geothermal field can be basically assessed. Now, after that, some dynamics of the fields, like how the extraction schemes can be established for the field, and then what is the feasible power potential which is available from the field. So these are the feasibility which can be actually applied with these challenges, like to establish that geothermal resource is also one of the viable alternative. A study was done by me and my student, one of my research scholar. So where the quantitative index is developed to show that how geothermal resource is also a relatively a promising alternative. And next, also the prospective significance levels of geothermal provinces has been also studied to establish that where and which field can be taken further forward for the pilot study if at all it is required. Then also delineating the geothermal reservoir for assessing the potential of geothermal extraction, and at the same time to study the various extraction schemes which will lead to that particular potential which is expected from that. And then some kind of study which is related to simulation studies, where it will also indicate what is the recovery from a particular reservoir in its lifetime of geothermal reservoir. So these are some of the feasible ways to study geothermal options. So we'll look into some of them and we'll discuss actually mostly in context of this renewable resources. Firstly, I will discuss about energy index concept. So what is energy index concept? For that, we will take these 5 alternatives of renewable energy: wind, solar, hydro, geothermal, and biomass. As we understand that why is it required to study these alternatives and study these alternatives in terms of energy index? As we understand, wind, solar, hydro, these sources are very much are dependent on the fluctuating sources, in the sense when we generate electricity from wind is an uncertain actually direction and speed which is not fixed in 24 hours. So it is a fluctuating source. At the same time, solar, in a daytime we have, or in a seasonal variation we can also observe, and that will not give us a sustainable source condition for generating the electricity, where in India we are very much dependent on grid-based electricity and we need a sustainable source for that. Similar for the hydro, so which is dependent on the source of water, again that in a rainy season, and if we just look into the dry season or like winter season where the water gets frozen, so this kind of situation creates a fluctuating source condition. Whereas geothermal, which is consistent, like in 24 hours, it will continuously give the same source condition. So this is one of the like a very significant factor which can be taken further into account to promote geothermal resource. So looking that into this particular factor into account, this 5 alternatives, these renewable sources has been considered as a possible alternatives. These were evaluated based on certain environmental and techno-economic aspects. So in environmental aspect, for example, this sources has to be judged based on these factors, like how good they are based on CO2 emissions, SO2 emissions, NOx emissions, air pollution, water pollution, sound pollution. And at the same time, they are how good they are in terms of techno-economic aspect, like for example land requirement, current energy cost, potential future energy cost, turnkey investment, water requirement, capacity factor, energy input output ratio, design period. So we have taken these aspects into consideration, and then each of these alternatives has been evaluated based on these aspects. So these aspects are considered as attributes or criterion for each of these alternatives, which has to be evaluated based on this. So data was actually looked into how the data is varying with respect to each of these alternatives. So as you can see, like CO2, all these 5 sources, it has been shown. So CO2, which is equivalent CO2, which is collected, and then it has been found that for geothermal and wind, it is lower compared to other sources, lowest in the case of wind, whereas for SO2, it can be observed that it is lowest in case of geothermal. NOx, which is again, it is lowest in case of hydro, followed by wind, and then the solar and geothermal, which is highest in case of biomass. Now land requirement, which is lowest in case of geothermal, and current energy cost, which is again lowest in case of geothermal, and potential future energy cost, again that is also lowest in case of geothermal. So there are a lot of positive attributes which can be observed here. Turnkey investment, which again found lower in case of wind and geothermal. Wind is showing the lowest, however. Capacity factor, which is highest actually in case of geothermal. So we understand the capacity factor, where how much compared to the maximum installed capacity which can be used from particular source of that particular plant. So energy input output ratio, again, which is lowest, which is the desired factor or aspect in evaluating a particular alternative, whereas design life, which is considered mostly 20 years, because it is not well established all over the global scenario. If you look into, there are certainly there are major plants which are currently in active phase, but still it has been few plants they consider 30, but few 20 as well. So we have taken the lower design life itself, and based on that we have evaluated for geothermal resource. Water consumption, however, this is one of the largest in case of geothermal, because water drives the heat which is extracted, so it is largest, whereas it is least for wind source. So now from here, this particular attributes of renewable alternatives, one can understand there are various criteria which needs to be taken into account to establish the fact that which alternatives are ranked better than the other. So different alternatives we have, then various criteria to be taken into consideration. So then finally to come out with some aggregated weight to judge different alternatives. So this turns out to be a multi-criterion problem. So multi-criterion problem, like schematically you can understand here. Here at the bottom you can see the different alternatives from A1, A2, A3, A4, A5. All those are representing solar, hydro, wind, then geothermal and biomass. And on the top layer you can see C1, C2, those are representing those attributes or criteria which is considered here. So out of whatever we have discussed, the criteria, 11 criteria is taken into consideration, and each of these alternative are evaluated based on this criteria, 11 criteria, and then they have ranked according to the aggregate outcome from this alternative criteria analysis what we have arrived. Now also you can observe here there is another alternative which is indicated by A6. So the entire idea was like giving the priority to the renewable alternatives which can meet the demand with least negative impact on environment, and by considering the techno-economic aspects. So as you have seen, the attributes are belonging to this particular two aspect. So this A6 is an hypothetical alternative where it will show always the ideal situation where it will always achieve the score of 1, let's say, Okay, so that we can compare other alternatives with respect to this A6. So that is why an hypothetical alternative is considered as A6, and then we'll achieve the score. Now, to study this particular alternative criteria analysis or do this analysis, this MCDM technique or multi-criteria decision making technique is one of the powerful tool, which is a decision-making tool which involves qualitative and quantitative parameters. Typically, it is used to evaluate the available alternative solutions over a set of criteria. So as you have seen, there are a set of criteria. All those alternative needs to be evaluated over those set of criteria, and so finally it leads to optimal solution. So there are various MCDM techniques which is shown in this particular graph. So AHP technique is a very common technique which is used almost in this energy domain also it is used. So concept of fuzzy is united with AHP, and this MCDM technique is utilized to do this criteria and alternative analysis. So let's try to understand one important factor which has to be the decisive factor for understanding the ranking of these alternatives. This is energy index factor. Energy index is defined as a ratio of the cumulative score of an existing which is evaluated over the considered wide range of criteria. So this is SA divided by SI. So it is a ratio of this SA by SI, where SI is the cumulative score of ideal alternative, which we have shown there as A6, as you have seen, ideal alternative evaluated over the considered wide range of criteria. So this energy index estimation, it has a certain steps which was followed, which can be followed further to achieve this energy index, which is starting from fuzzifying the SATI judgment scale, and then further it follows evaluating each criterion over rest of the criteria. So because how important one criteria compared to the other criteria, that is important factor to be taken into consideration. So evaluation of each alternative over each of the criteria, then further it follows, and a development of performance matrix is actually required, and estimation of fuzzified score, and then defuzzification and computation of cumulative scores for each alternative is done, and which finally gives the evaluation of energy index, that is SA by SI. So with all those analysis, which is underlying steps of finally reaching to this energy index value, as you can see here in this particular this table, it has been shown how this all alternatives A1, A2, A3, and so on, this which is depending on this defuzzy by this triangular members value which has been shown here, and then finally we achieve at defuzzified score, which is which is for lambda 0.5. With respect to that, you can see here the value which is assigned for each of these alternative A1, A2, A3, A4, and A5, and finally energy index, which is obtained dividing each of these defuzzified score with respect to the score of this hypothetical alternative A6, and then we get the energy index value. And as you can understand, so this A6 obviously it will have the value of 1, and A3 has got the highest value, that is 0.402. So A3 is nothing but it's a geothermal source itself. So geothermal source which achieves the highest energy index, followed by hydro, wind, biomass, and solar. So what is the final learning outcome here, that based on those criteria, which was environmental attributes and techno-economic attributes, geothermal shows a very promising source in terms of when we have evaluated based on those criteria, followed by hydro, wind, biomass, and solar. However, we have not explored geothermal in case of Indian context. So this lies as one of the challenging factors to promote geothermal in India. So to understand this aspect, it is important to understand how much and how wide is the geothermal information base in context of India. So there are some of the information base which is available those are geochemical analysis, cumulative discharge, gas geothermometry estimation, resistivity, area, temperature logs, etc. And at the same time, these were the existing some data. However, for a shallow depth of geothermal reservoir spread all over the country, as you can see, it is available. But there are some other criteria are also required to understand the significance of these different fields which are existing, whether it can be taken for the direct utilization of geothermal resource or energy. As you have seen, we have three forms of utilization. One is electricity, another is steam and thermal. So another two factor was required: useful resource base of each of this promising geothermal localities or field, whatever you say, then utility score. So this two of them was studied by us and obtained this. And finally, we could frame this particular problem in terms of selecting these six geothermal locations as our study locations, which again can be considered as different alternatives, like Puga, Chumatang, Manikaran, Tapoban, Tatapani, spread over the different parts of our country, which has been indicated by alternatives A1, A2 until A6, six alternatives. So suppose we have these six fields, and then we want to study the prospects of this particular field based on certain criteria. These 9 criteria as based on certain available information base, and which some of the criteria which has been assessed by us, which has been useful resource base. As you can see here, useful resource base, estimated temperature of thermal water, minimum and maximum. Utilization score means how best it can be utilized from that particular field or location. Cumulative discharge, gas thermometry information, minimum resistivity, maximum resistivity, and area of geothermal field. Means what is the extent of that particular geothermal field. Why this particular study is required? This is one of the question arised when we started studying this fact, is because simply establishing some kind of potential from one particular geothermal reservoir is not important. When we propose some uncharted domain, it is important to take stakeholders also into account. Now, for that, it is important to establish the fact some of these fields are so promising, where the pilot study can be done, where this is to establish the fact this is one of the viable and very strong options to explore. So that is why this study is actually done, where now we have taken the same strategy what we have done for different renewable alternatives. So different geothermal fields, which are 6 fields which we have identified, and those are evaluated based on this 9 criteria, as we have discussed here, this 9 criteria. These are the attributes which are representing this, which are going to represent the significance of each of the geothermal field. At the same time, these are the factors which contributes to the potential of that particular field as well. So in this table, as you can see, this 6 fields, which is in here, it has been mentioned as A1, A2, and A6, so on. And then criteria, that 9 criteria as we have discussed. So this value which has been actually assimilated, and accordingly, this 6 fields has been evaluated. So after the evaluation, there is a lot of underlying work which goes behind this. It has been found that among the 6, Puga, which is located in northern part of our country in Kashmir Valley, which achieves the maximum score of 0.46, followed by Chumatang, Manikaran, Tatapani, Unha Dekhed, and Tapoban. So this indicates that the link between the scientific study and the stakeholder, they can just understand that how significant among all these field location, and which should be promoted when we are in the exploratory stage of study. So Puga can be taken further to establish either the pilot plan or to explore further for industrial scale electricity generation. So taking this into account, we have also further taken Puga as a location where the case study could be further done. And the next part of my study focuses on that geothermal energy status and potential assessment, which was again, as in last slide I have discussed, which the Puga has achieved the highest significance index. So that was the field which was studied in next stage. So where, as you can see here, the Puga, which is located in the northern part of country in Kashmir. So geographical location and terrain of the Puga geothermal field is one of the challenge, because accessibility is a problem in this zone. However, in terms of potential, it has certainly shown one of the promising potential. So also due to certain study, it has also been found that Puga geothermal valley has quite good thermal manifestation zone with a very wide area of 4.3 kilometers square. So what is thermal manifestation zone? Thermal manifestation zone is basically some surface activities are widely observed in this particular geothermal field, and which is indicating also the potential of this particular geothermal field of Puga. So we have taken that into account. So the information base was partly available for this field, where that sulfur deposits from the springs was observed, and also there were a lot of boreholes have been drilled to explore that. However, all the boreholes are not studied. Out of that, only few of them, 7 were logged, and some temperature data was obtained from that. Second limitation was that though data was obtained, but it was limited to shallow depth, 382. As you have seen that in a global scenario, how deep the geothermal reservoirs were explored, like 2,000 and 3,000 meter depth. However, here you can see it has only been explored till 382 meter, which is a shallow depth. So where ground heat source zone lies itself. Now, some of the geophysical studies were also conducted in this region, and heat flow studies also indicates some promising value. And in a recent past, magnetotelluric studies, which actually is conducted to study the resistivity of that entire zone. Resistivity is one of the parameter which indicates the location of the geothermal heat, which can be identified, and where the geothermal bore well can be installed to extract the hot water for electricity generation. So from this shallow depth study, this is what is obtained, the temperature log, how temperature varies with depths. Obviously, it increases, but it is at different wells, different thermal gradient. As I have already indicated, thermal gradient is one of the important parameter. It is not same. So it varies between 0.5 to 2.5 degrees centigrade per meter. And also some higher gradient is also observed in some portion, where 5.8 degrees centigrade per meter, which is quite high, indicating the higher potential. Now, this bore wells were actually ranging between shallow depth, within the shallow depth from 28.5 meter to 384.7 meter. So again, there was another information base which is available in terms of magnetotelluric study, which is, again, I told you, like resistivity data for the entire zone. So different profiling has been done, profile B, C, and D. Those are actually different layers, different vertical profiles, where the resistivity data was collected for a very greater depth, like which was not possible from the, or which was not done from the bore well. It was done 6 kilometer or 10 kilometer depth it has been achieved. And we have taken this information base further for our study, and then moved into developing the conceptual model for this particular Puga geothermal field. And this conceptual model further leads us to characterize the field which was required to assess the potential of this particular field. So characterize the field, what we mean by that characteristic of this particular field, which will be taken further for assessing the geothermal potential in terms of how much power can be extracted from that particular field, was characterizing the hydrogeothermal characteristic of that particular field. So there are a lot of parameters associated with this particular aspect, and that was what is the characteristic means. So those were assessed from this. So there are a lot of works which is underlying behind this particular study. The study can be found in this particular publication, which is cited here at the bottom. And then there are a lot of simulation studies which correlates with the fluid flow and heat transport modeling. So fluid flow, where we have a geothermal fluid which flows, along with that it transports the heat, and that heat is extracted through the borewell. So we are not going in detail with this modeling. So this is a complex modeling which is underlying beneath this particular study, and that finally lead us to assess the extractable power from various depths of that particular geothermal field. So we have identified 4 different depths, which was designated by reservoir 1, reservoir 2, and reservoir 3, and reservoir 4. And then it has been found what is the feasible extraction temperature from these different depths and corresponding power, which again depends on the extraction temperature. So 4 different reservoir actually indicates 4 different depths. So as you can see, for reservoir 4, which is indicating the highest power extraction, which is at the highest depth. So this power can be calculated from this. So entire simulation and study was required to get this extraction temperature actually. So then finally, this was one of the objective to find or assess the potential which can be obtained from this. It has been found that from different depths, as you can see, nearly about 10 megawatt, we can see 421 megawatt is possible to be extracted from the different depth of this particular geothermal field, which is studied here. However, taking the typical conversion efficiency into account, which is 12% of this particular estimation, which shows that minimum of 1.2 from the very shallow depth, which is reservoir 1 indicated by reservoir 1, and then highest of 50.4 megawatt electric, which can be obtained from this particular field. So this is one of the promising value in itself, actually 50.4. So this value, again, it indicates that promising power, which potential from reservoir 4, which is less than 2000 meter. As you can see here, it has been indicated. Now reservoir 4 is at 1875 meter, which again have a very high recovery factor compared to the other reservoir at shallow depths 1 to 250. So recovery factor is not so high in the sense, because more deeper we go, we have the crustal heat which is available, and that actually keeps replenishing that particular whole source. And in shallow depth, so that is where we miss that particular component. So that's where the deeper zone is more promising compared to the shallower zone. So recovery factor, as we have already discussed here. So what does it mean? Recovery factor, actually, it is the ratio of theoretical heat which is stored within that particular resource, that is the reservoir, which is with whatever power which can be extracted divided by this particular theoretical heat gives the recovery factor. So power, which we have already calculated here, as you have seen in last slide. So that divided by, so whatever the total energy which we can extract, that can be estimated from that simulation study, as you have seen. And then this total heat energy is stored in that rock and fluid of that reservoir, which again can be estimated. As you can see, it is constituting of the total heat of which indicates the B is indicating the block, means the rock or porous block thing, and then F is indicating the fluid. So in the fluid you have the stored heat and then the block, so together it constitutes the total heat stored. So the ratio of that extractable energy divided by this theoretical heat, it gives the recovery factor. As you can see here from the different reservoir, which again I'll repeat that it indicates the different depths, so where the recovery factor is varying with the depth, and it is not necessary all the time the deeper reservoir will give give us the highest recovery factor. In this case, it has been found that some intermediate, which is just above the reservoir 4, where recovery factor is quite high. So this estimated, the 2 color is indicating it is for recovery factor for 20 years and 50 years. So if we just consider the reservoir life for 20 years and for the 50 years, that's how this 29% and 65% recovery factor, as you can see here. So this is how it shows that how promising geothermal energy source is in itself, where the value assessed for one field, it shows that 50 megawatt, near about 50 megawatt electric, which is again an indication of very potential resource, which is feasible from this particular source. So let me just then conclude for this entire study, some of the takeaways which we understand from this lecture itself, like we could understand that geothermal energy is a viable option and a strong member to strengthen the renewable energy basket. Energy index of geothermal source, which was indicated here as A3, which is higher than all other renewable sources like hydro, wind, biomass, and solar, which again infers the fact that it is the source that supports the increasing demand with least negative impact on environmental and techno-economic factors. Now, the third takeaway is like when we are in the initial stage or exploratory stage of study, where we have to also take into account the stakeholders' contribution, and to support their opinion, we need to also furnish some of the facts. So it has been found that Puga geothermal field, among all the other fields, it shows a very promising and with the highest significance level, followed by Chumatang, Manikaran, Tatapani, Unavadekhed, and Tapoban geothermal fields. So the initiation of the pilot plant, etc., can be taken at Puga geothermal field, followed by the other as it has been indicated. And also in terms of the numerics, if we just look into the electric potential, which was quite promising, as you can see at the reservoir 4, which is at nearly about 1,800 meter depth. So it is 50.4 megawatt electric, which can be expected from Puga geothermal reservoir at one particular depth. However, there is possibility to have the exploration from the different depths. So that will again be the cumulative. So this is what is the minimum expected potential which can be expected from this field. So this with this some of these takeaways, let me conclude my talk today here itself. So thank you.